Simplify the following expression to positive exponent only. The first thing I noticed about this problem is that there's three quantities, each raised to an exponent. So that's going to indicate to me that the power rule is going to be applied 3 times. Once in green, once for the blue quantity, and once for the yellow. I'm going to start with the blue quantity because I've noticed that in math, anything raised to a 0 exponent is pretty unique. It's equivalent to 1. So we're going to start there. Okay? Which means I'm going to copy everything that I'm not going to use down. Okay. So there's the green quantity in yellow. And now we have 5 is a base, x is a base, y is the base. A common misconception that students have is that they forget to raise the base of 5 or use the power rule with the base of 5. We know that if I don't see an exponent, that means that there is an exponent of 1. So this is saying 5 to the first, all raised to the 0 power. Power rule says to multiply the exponents. 1 times 0 is 0. And now we do the same for the x base. X to the third, all raised to the 0 power. 3 times 0 will give us x to the 0 power. And lastly, y to the negative 2, raised to the 0 power, means again we multiply. Negative 2 times 0 is also 0. Which basically tells us that each of these terms inside the quantity, 5 to the 0, that's equivalent to 1. X to the 0, equivalent to 1. Y to the 0, also equivalent to 1. So this whole thing looks like it cancels out, but we know in math that that's really just all simplifying to 1. Copying the rest of the problem down. And now our problem looks a lot easier. We're going to take our original green quantity, which is represented here, and again, we're going to apply the power rule. Again, don't forget, negative 4 is a base. It has an exponent of 1. So to use the power rule here, I'm going to take that 2 and multiply it by each exponent, keeping the bases the same. Very important. So negative 4 raised to the first, 1 times 2 is 2. Negative 4 to the second. X to the third raised to the second power is 3 times 2 is 6. Y raised to the negative first power to the second is negative 1 times 2 is negative 2. Again, bases stay the same. And while we're here, let's also complete the power rule on the bottom. Did you forget that 2 is a base? Hopefully not. 2 to the first. 1 times 3 is 3. 2 to the third. X to the fourth raised to the third is x to the 12th. And y to the first. 1 times 3 is 3. Now, we know some of these things. We know negative 4 times itself, or negative 4 squared, is negative 4 times 4. Negative 4 is positive 16. 2 to the third is 2 times 2 times 2, which is 8. And now, looking at our problem, I notice I have one negative exponent. And remembering what a negative exponent does, we use the word reciprocal to indicate that it's going to move from the top, or the numerator, down to the denominator. 16. I'm going to put that right at the end here. Y squared, because it becomes positive in the denominator. And now I can see a quotient rule. Quotient rule says if I have the same base, x, we can subtract the exponents. 6 minus 12 would give us x to the negative 6th up top, But if we wanted to keep it positive exponents only, 6 minus 12 is negative 6. That would be up top. We're going to actually write that in the denominator. X to the 6. I can also think of this as this has 12 x's, this has 6 x's, there's going to be 6 left in the bottom. And then we have a nice little product rule in the form of same base y, each raised to an exponent. We know we add the exponents. 3 plus 2 is y to the 5th. And lastly, another common mistake students make is looking at this fraction here. We should know that fractions can be split up, so I could, if I wanted to, make this problem look like this. 16 over 8 times, well, we'd need a 1 here, and then on the bottom, x to the 6th, y to the 5th. And now this is something that you've done in many early grades. 16 divided by 8 is 2. 2 times 1 is 2. Over, bringing these terms down, gives us the final answer. 2 over x to the 6th, y to the 5th as our final answer.